realistic situation. Right? You're beginning algebra students. You'll probably see more of these sort of things. What do you guys do? Do you remember?
Is it that tree?
You need to reduce every fraction you see to lowest terms in your life, even if they're improper. This is an improper fraction. You don't write it as a decimal because you reach for your calculator. You don't write it as a mixed number. Those numbers are, again, what? Those are gone. They're out of your life to some degree. So every fraction you see needs to be reduced to lowest terms. And that's why we reviewed last week simplifying fractions. So when you get this as an answer, you're not done. What do you have to do with 32 and 6? Well, you're going to reduce the fraction, but what was that process for each of these numbers? You're going to use a factor tree. Is that right? You use a factor tree for the 32, a factor tree for the 6. What do you guys get when you do that? Do you guys know that 32 is written as 2 times 2 times 2 times another 2. There are 5 2's being multiplied together to get the value 32. And how do you break 6 down? Is that 2 times 3? So you broke these numbers down into the product of their prime factors via your factor tree method. You remember that? Now what do you use? Cancellation. You're right. 2 goes away, 2 goes away. Does a 3 go away? No. So remember, like I said, I personally circle everything that's left. And so then now you get x equals, what is this? 16 over 3. What do you know about this fraction 16 over 3? Anybody know? Isn't this reduced?
Yes.
This is reduced to lowest terms. So what does that mean?
We're done.
It means you're done. That's right. You're done. This is the answer. Do you want to write this as a mixed number? No. Do you want to write this as a decimal? No. You write it as a reduced fraction, even if the fraction's improper. Okay? Yes?
So would it be wrong if I did 5 1/3?
Yeah. I would just say no. Do you guys want to know why people rather write it as a mixed number? Did we talk a little bit about that? About the coach scenario? Did I mention how coach? What did coach say when you showed up that day? So do we have to reduce this, we have to reduce that fraction, or can I write it as a mixed number? What did coach say? Whatever you want. But the truth is you can't do whatever you want. You're going to have to write it as a what? Improper fraction. A lot of times people even reach for their calculator because they don't even want to do what? Reduce this to lowest terms. It's drama. It is true. Right. Yeah. All you got to do is remember that method. See, I don't understand. Like sometimes, you'll give people test questions, and the first 10 maybe, okay, reduce these fractions to lowest terms. And they'll do it. But then when they solve an equation and they get 32 over 6, they may not what? Do it. So it's kind of, there's an inconsistency there. Okay, so again, the only reason, well, one of the big reasons why you study simplifying fractions or you review simplifying fractions is because when you get to solving some of these equations, you can write your answer in a simplified, way. So that's why you go through that exercise. It's not an exercise that just exists, on its own without a reason. Okay, so what are you guys going to do every single time you have an answer that's a fraction? What do you do? Reduce to lowest terms. Simplify it. Should we create a song that reminds you? I simplify my fractions. You'd be surprised at what works. You'd be really surprised at all the silly things that actually work that help you remember things. It's like the stuff I do here is very silly. I know that. But outside in real life, do you guys think I'm silly? Ed, am I silly? Exactly, I'm not silly. So why am I silly here with you? Because I know from experience, you're going to remember this stuff. It makes an impression on you. When I was in elementary school, I remember I learned this kind of in the 4th grade. Mr. Kinsley, I didn't know what 6 times 8 was. I went through all of the sort of, I could do the multiplication, but when it came to 6 times 8, for some reason, I couldn't remember. 6 times 8, what is that? And Mr. Kinsley noticed. He calling me, 6 times 8. I didn't know what. Couldn't give him the answer. So you know what he did? He made a song and dance called the 6 times 8 song. It's 6 times 8, and he danced, and he made a song as 48. And he did that for a few minutes. I'm not going to do the dance. I'm not going to sing the song. But 6 times 8 is 48. And he did this wacky song and dance. And to this day, when I see 6 times 8, I know it's 48, and I remember the dance and the song. So the interesting thing, like I said, what gets you to remember sometimes are these silly things. And that's really, I find, goes a lot further than anything else, you know, making those kind of remarks. But yeah, in real life, no. Let's test. What's 6 times 8? Anyone not know? Where? Yeah. All right, where are we at? We reduce our fractions. Okay, here we go. What about when you see x over 4 equals negative 3. This is different now.
Do you times it now?
Well, yeah, what do you notice is happening with x again? Do you guys know? 4 is being divided into x. So how do you undo division?
You multiply.
Right, you multiply. But what do you multiply by? 4. By the number that's doing the dividing. And you're right, in this case, it's a what? It's a 4. So you multiply both sides by 4. Don't we have that property over there? Isn't that the first? It's the first one. So, I mean, and this is an interesting thing. I have found for some reason, some students really do need this to see this step. And that's fine. I'll show you. But do you guys remember when you multiplied fractions together last week? How did you multiply fractions? Across. Is this 4 even a fraction? Now it is. So some students I found really need to see this, and I'll show it to you. You know, isn't that interesting? They need to see 4 over what? And now tell me they need to go through this, and that's fine. So what's 4 times x? It's 4x over what's 1 times 4? 4. So I find, and then negative 3 times 4 is? Negative 12. I find really that this goes further with some people. They need to see this step. And all right, fine. This is 4 times x, right? There's multiplication here. You're going to now use the cancellation property. Your 4's go away. You're left now with x being the value of a negative 12. That's what you're left with.